Dr. K Ranjith Kumar, sir. Brief report about to K Ranjith Kumar, sir.
Okay, thank you, Anil sir, for giving this opportunity. Good evening, everyone, and welcome you all. Myself, K Sujata, Assistant Professor from EEE Department. It's my pleasure and proud to introduce Dr. K Ranjith Kumar, sir. Dr. K Ranjith Kumar, sir, working as an Associate Professor in Electrical and Electronics Engineering Department, Vagdevi College of Engineering. Sir received his PhD degree from JNTUH. Sir have almost 11 years of teaching experience and 3 years of research experience. Sir research interests are renewable energy and DC to DC converters. Sir have almost 20 research publications from various reputed journals. Sir handled a research project worth of 3 lakhs funded by TEQIP3. Sir received the award Best Researcher in Renewable Energy and Young Scientist Award. Sir organized AICTE funded 4 lakh worth 2-week FDP on renewable energy sources integration to power systems, and also conducted many more programs like workshop for students and faculty to enhance the knowledge. Sir is the professional member of IEEE, ISTE, IAENG and WRC. In today's session, Sir is going to discuss about enhanced geothermal system design and biomass yield prediction using ML. Once again, I happily welcome you, Dr. K Ranjith Kumar, sir. Thank you, sir. Thank you, one and all. Thank you, Anil, sir.
Thank you, madam. Now I request Dr. K Ranjith Kumar, sir, please hand over this session.
Sir, I am audible?
Yes, sir. Yes, sir.
Thank you, ma'am, for introduction. Good evening, everyone.
Good evening, sir.
First and foremost, I would like to thank coordinators, principal, management of Jayamukhi College for giving this opportunity. Today, I'm going to share the insights on today's fascinating topic. Why I'm telling this is fascinating topic means it is the combination of RES and machine learning. So it is a deadly combination, RES and ML. So that's why I told as a fascinating combination. So is the presentation is visible, sir?
Yes, sir. Visible.
So today's topic is enhanced geothermal system design and biomass yield prediction using ML. First, I would like to decode the title. What is EGS? EGS means artificially engineered geothermal reservoirs for energy extraction. So we have the conventional geothermal systems and enhanced geothermal systems. Enhanced geothermal systems are artificially engineered geothermal reservoirs. What is biomass yield prediction means? Estimating the energy potential from agricultural bioproducts. What is machine learning? Machine learning handles the complex and non-linear relationships like renewable energy dataset. Renewable energy sources having the non-linear complex relationship. So machine learning is also capable to handle this relationship to predict the outcomes. So first, I would like to give the overview of presentation. So in this presentation, briefly, I introduced the EGS and biomass energy and the role of machine learning in these sources, and I will show some case studies and results. Then I will conclude the session. So before starting the session, everyone know the importance of energy. So this picture shows the complete view of energy. See left hand side, you can see the different sources. Those sources are including fossil fuels, renewable energy sources, and Right side, you can see what the outcome from these sources. This yellow line connects all the sources: oil, coal, natural gas, uranium, solar, wind, hydro, geothermal, every source. All these primary sources are used to generate the electricity. So that electricity, when we are using primary source as coal, then we can say that is a thermal power, uranium, nuclear, that we know. All these sources are primarily used to generate the electricity that can be transmitted and supplied to the various consumers. And there is another line, blue, so that connects the sources which are used to give the liquid fuel for transportation. And there is another red line that sources, wind, for example, wind, geothermal, biomass. So this can be used to, solar, geothermal, biomass. This can be used to generate the heat energy. So we can use that heat energy for different purposes. So like that, gas. So this is the importance of energy. Energy is needed at every stage of modern life. We know that energy consumption is an essential parameter in determining the country's development also. So that is the importance of energy. So here the different sources are there: fossil fuels and renewables. Fossil fuels having the disadvantages, that is by next few years fossil fuels going to vanishes, and it is depleting the sources and polluting the environment. So every country now shifting towards the renewable energy sources. We know that there are different types of renewable sources like that. I would like to give some statistics on the power generation in India and installed capacity. See this left side, you can see the various types of sources generating the energy. As of 2024 March, the billion units are 1731. And right side, you can see the total installed capacity, that is 441. India target is by 2030 by using only renewable energy sources to achieve the 500 gigawatt. So this slide shows the percentage of energy generated by fossil fuels and renewable energy. In 2010, most of the energy generated by using fossil fuels only, that is 84, and 16 is the renewable. 2020, it is slightly decreases 77, and renewable sources increases to 23, and aiming to 2030, that is 50 and 50. So this pie chart gives the statistics about only renewable energy sources, major contribution by solar and wind, and remaining all are biomass, geothermal, small hydro. This slide gives the overview about the geothermal power equipments, not about geothermal energy. We have the different types of geothermal power plants, like dry steam plants, flash, binary. So we'll discuss what is this, but as of now 2024, this is the statistic. It is increasing from 2019, and 2027 also it is going to increase. So all these renewable energy sources having the advantages and disadvantages. Advantage is clean energy available throughout the lifetime, but disadvantage is depends on the weather conditions. So it is highly volatile. It is very important to forecast the energy from the renewable energy sources. There are, sir, is it okay? I'm audible?
Okay, sir.
Okay. So there are three types of forecast models, basically physical models, statistical models, and machine learning models. Physical models uses the laws and equations. For example, solar, the basic law is photovoltaic effect, and there is an equation related to sun radiation, temperature, and current generated by the solar. So based on that equations and laws, this physical model works. The strength of this physical model is it is a detailed and accurate model, but challenging is, so it is computationally very burden. So you have to solve the equations, lot of equations. There is another type of model, statistical model. The approach of this statistical model is based on the historical data. So when the historical data is given, then it is identify the what is the pattern inside the data. Based on that, it predicts the energy. But the disadvantage or challenging task in a statistical model is it cannot handle the unexpected data. For example, weather is unextremely changes, then it cannot accurately predict that. So there comes another, that is machine learning model. Machine learning model will discuss. It learns from the data. We already told that it handles the complex and non-linear relationships in the data set. It learns from the data and it predicts the outcomes. The challenging task in the machine learning model is it requires a large data sets. Our objective is to develop the machine learning model to enhance the EGS and predict the biomass yield. So that is today's topic. So first, I would like to tell what is machine learning. I think the previous speakers also give about that machine learning. So I would also like to give some insights about the machine learning. So machine learning is a branch of artificial intelligence. It learns from the algorithms. From the algorithms, it uncovers the hidden patterns, what are that, and it makes the predictions when the new data is given without writing any explicit program. So machine learning learns from the data, predicts the outcome, it takes the decisions, it remembers and analyzes. It recognizes also. It is used for face recognition, speech recognition. We are experiencing all these in the internet sources while we are using mobile, everything. In simple language, what is machine learning? Machine learning is an application of artificial intelligence where the system gets ability to automatically learn and improve based on experience. For example, this is ordinary system. When artificial intelligence is adapted to this ordinary system, then it is ability to learn and predicts. So it improves by its own. So in simple words, we can tell this is a machine learning. So what are the problems in the machine learning? There are basically three types: classification, regression, clustering. Classification problem having the two types of solution, that is yes or no, 1 or 0, or true or false. For example, classification of mails. So whether it is spam mail or not. So that is the real time example for classification. Classification predicts the discrete value. That means 1s or 0. Regression predicts the continuous value. Load forecasting, energy forecasting, that is comes under regression. Clustering means different types of persons are grouped into the different types of clusters. For example, in the e-commerce business, the customers are based on their past history of data, they will clusters into the different groups. So basically, we can handle these types of problems in the machine learning: classification, regression, clustering. As of now, these are the applications in the manufacturing, healthcare, e-commerce, automobile. Now we are applying this machine learning into predict the renewable energy. What are the different types of machine learning? Supervised, unsupervised, reinforcement. Supervised learning is mainly task-driven approach. Unsupervised is data-driven. That means in supervised learning, the learner is able to learn from the tasks. That is, the learning specifically that is designed for solving a particular task. Like I told, spam mails, detecting of the spam mails. So it is specially designed for that particular task. And predicting the load forecasting, future prices. So all these are task-driven approaches. Data-driven approaches means where learns directly from the data set. Reinforcement is the learner here in this called as agent. The agent is learns from the interacting environment. That means by feedback, by giving the feedback, he learns by mistakes. So in other words, supervised learning. When the student is learns under the guidance of teacher, then it may be supervised learning. If he learns by his own unsupervised learning. So this example gives the complete view about the unsupervised learning. So this side you can see the input raw data which having the different vegetables. When this raw data is given to machine learning model, then it clusters into the different groups. So this is one cluster, and this vegetable comes under another cluster. This is. So this type is called as the unsupervised learning. Generally, we will give the unlabeled data. That means only we'll give input, we don't give the output. That is called as the unlabeled data. Supervised learning is having the labeled data. For example, here this carrot, tomato, this is capsicum. So this is labeled, the data is labeled. When machine learning model is learned with labeled data and it is predicts the output like it is carrot, it is tomato, then it is called as the, so you are giving this test data, training data and test data, then it predicts the output. This is called as the supervised learning. How do you choose which learning algorithm to use for your applications? Supervised learning is used for prediction. If you want to predict the weather, if you want to predict the energy, so then you have to use the supervised learning. Unsupervised learning is for clustering, splitting the data into the different clusters. Our objective here it is predict the energy from the sources. So we have to go for the supervised learning. Supervised learning basically having the two types of problems, that is classification and regression. So what are the classification algorithms we have? So classification having the different types of algorithm, regression having the different types of algorithms. Maybe same algorithms can be used for both classification and regression. So these are the few examples: a decision tree, random forest, logistic regression, naive Bayes. So here the some more algorithms. So we know that machine learning is three types: supervised, unsupervised, reinforced. Supervised learning having the two problems, regression and classification. These are the algorithms under regression. These are the algorithms under classification. Similarly, unsupervised algorithm mainly for clustering. These are the algorithms used for clustering, and these are the algorithms used for reinforced. Our focus here in this supervised learning. So here one of the algorithm is a decision tree, and another one is a random forest. If you want to understand the random forest, first you have to know what is the decision. I would like to give some insights on the decision tree algorithm. So decision tree uses the tree shaped diagram to determine the output. Decision tree having the branches and nodes. So the terminology I will tell. So here in this image you can see the vegetables, group of vegetables. You are giving the condition. Based on the condition, it is classifying true or false. This is the one branch and this is the other branch. If you are giving the condition like color equal to red, if it is true, then it is goes to right side. Otherwise, it goes to left side. If you want to further classify for accuracy, you are giving the another condition, that is diameter is greater than 2. Then if it is true, then it is comes to right side, and other false left side. So basically decision tree works like this. So to understand the decision tree, you should know this terminology. So what is the entropy? What is the information gain? Leaf node, decision node, root node. Entropy is the measure of randomness or unpredictability in the data set. So basically raw data having the randomness. With that randomness, the accuracy you get, that is highly impossible. So what we have to do, we have to reduce the randomness. So that is called as the entropy. See here, this is the data set. This data set having the high entropy, that means randomness is very high. So what we have to do? We have to split this initial data set into the two. So based on the condition, so that condition, how we can give the condition to reduce the entropy, that we'll see. So here this initial data set is split into set 1 and set 2. If you observe here, the randomness is decreases when compared to initial data set. So entropy here in the set 1 and set 2 is decreases. So this even initial data set having the high entropy and this having the lower entropy. After splitting the initial data set, the randomness is decreases. So in this way, we have to decrease the randomness by giving the conditions, split the data. Next term you have to know, that is information gain. It is the measure of decrease in the entropy after split the data set. See here, this is the initial data set having the high entropy. We are splitting based on the condition, then entropy is decreases. So the information gain is the difference between these E1 and E2. So this is called as the information gain. So what it tells, information gain majorly tells that it decreases in the entropy. That means randomness is decreases. That is the information given by the information gain. Then you have to know about leaf node. Leaf node, I already told, decision tree having the branches and nodes. Like that, real tree. Leaf node carries the classification or the decision. Decision node has the 2 or more branches. See here. This is called as the decision node. This decision node having the 2 branches. Again, this is also called a decision node. This is also having the 2 branches. This is also decision node having the 2 branches. But this is called as the leaf node. So finally decision is made. That node is called as the leaf node. So what is root node? Topmost decision node is called as the root node. So this is the topmost decision node. This is called as the root node. So I hope I am. So I think whether this is the online session, whether the people are listening or not, whether they are understanding or not, I don't know. So is it up to now so far it is okay? Please respond.
Sir, okay, sir.
Yeah.
Please continue.
Okay, sir. So to analyze this decision tree algorithm, these terms are very, very important. So I will take a simple example. How does the decision tree work? See, in the forest, we can see the different types of animals. So what is our problem? We have to classify these animals. That is our problem statement. So here this data, this is the raw data. This raw data having the high entropy. That means randomness is very, very high. So what we have to do? So this is our training data set, color, height, and label. These called as the features. So in the data set, there are 2 types of variables, features and target. What is feature? Feature means independent variable is called as the feature. Dependent variable is what you are going to predict, your target. Your target is called as the dependent variable. So basically training data set having the features and target. Color and height is feature. And this label, maybe you are predicting it is elephant, a giraffe or monkey. So that is your target. So how you are defining the target based on the independent variables. Here the features are color and height. So first, here this entropy, randomness is more in this data set. What you have to do? You have to split the data. In the decision tree, the initial data set is splits into different branches. So how can we split? We have to split the data into by using the conditions. So how can we write the conditions? So first we have to calculate the entropy. So in the data set, how much the randomness is there? So that can be, this is the formula to calculate the entropy, summation I equal to 1 to k p of value I log base 2 p of value I. So by using this formula, we can calculate the entropy. Before that, you have to identify the total number of animals. So giraffes are 3, tigers are 2, monkey 1, total 8. How many types? 4 types. So k equal to 4. So here by using this formula, so there are 4 sets. So you have to apply the formula for 4 different animals. So first you have to take the entropy for giraffe 3 by 8, log base to 3 by 8. Next we have the 2 tigers, so 2 by 8, log base to 2 by 8. Next you have the 1 monkey 1 by 8. So sum of all these, and after done the mathematical operation, you will get the entropy, that is 0.571. We have to calculate this entropy for every step until randomness becomes, entropy value is 0. And also subsequently you have to calculate the information gain also. Information gain is high entropy minus low entropy. See how we have to select the conditions. See here, for example, I am taking these conditions: color equal to yellow, height greater than 10, color equal to brown, color equal to gray, diameter is less than 10. So based on this condition, you have to split the initial data set. We have to identify that which condition gives the high information gain. So that we have to know. I am assuming color equal to yellow may give the high information gain. So that's why I am taking this condition. So when you are giving the condition color equal to yellow, then true, then all the animals yellow comes to one branch side, false, then other side. Still this data having the randomness. It is why? Because here the animals, both animals are there, here the both animals are there. Again, what you have to do? You have to use the another condition. After giving the condition color equal to yellow also, the entropy is decreased slightly but not completely. So now we have to use the another condition. On this side, I am giving the condition that is height is greater than or equal to 10. Then it is true. So basically giraffe is having greater height, so comes one side, and tigers comes to the another side, false side. Similarly, the same condition this side also. Again, these animals are classified. Now this is completely, randomness is becomes, entropy becomes 0. So now when the new data set is given to this decision tree, with high accuracy it predicts the animal. Why? Because here animals are classified. Giraffe is classified, tigers, monkey and elephant. Now when the new data set is given, then it is accurately predicts. So this is decision tree. Based on this decision tree only, actually in this presentation I'm using the random forest algorithm for EGS and biomass energy. So to understand the random forest, first you have to know how the decision tree works. Why? Because random forest is also same, but it uses the multiple decisions. Random forest is called as the ensembled learning method of algorithm. Ensembled means it using the multiple learners, multiple machine learning models. For example, when you buy a phone, then you will take the information from different, your friends, your neighbors, your relatives. So you are depending on the decision of multiple. Like this random forest also uses the multiple decisions. Instead of depending on the single learner, you are buying the phone from the opinions, taking opinions from the different persons. A majority opinion you will take. Same here also. Random forest uses the multiple decision trees. So like this is the decision tree 1. For example, this decision tree predicts the output like apple. another decision tree predicts for the given data set. Directly I am telling this is the decision tree is predicting this fruit as the output. And similarly, so majority is what? Majority is the apple. So final decision is apple. So like that, random forest works. Why we have to use the random forest? Because it has these advantages. There is no overfitting, high accuracy. Even though large data is missing also, random forest accurately predicts the output. So if there is overfitting, then there is a chance of accuracy is less. So that's why in this random forest algorithm, there is no overfitting. So I already taken the decision trees, multiple decision trees. So directly I'm telling this is the one decision tree. So this is the initial data set. Here this having the different types of fruits. We are classifying based on that means splitting this initial data set into the different branches. So the condition here I'm taking is diameter greater than or equal to 3. If it is true, then comes to right side, or false, then these are cherries, these are apples and oranges. So diameter of apples and oranges is greater than 3, so comes to this side. Cherries diameter is small, so comes to false side. So as we discussed, you have to split the data by using conditions until the entropy becomes 0. That means randomness is 0. Still, you have to use the another condition, that is color equal to orange. If it is true, then orange comes to this side, otherwise false. This is one decision tree. Like that, another decision tree I am taking. This decision tree uses, first we are splitting on the basis of is color equal to red. Again, it classifies like true and false. Again, there is a randomness is there. So you are using the another condition is shape equal to circle. So cherry is having the circle shape, so comes to this side, and apples comes to this side. This is decision tree 2. There is a third decision tree. This is using the condition diameter equal to 1. So cherry's diameter is very small, so it is true, comes to this side. False. These fruits diameter is high, so comes to this side. Another condition is these fruits grows in summer. So apples, so does not grows in summer, so false. Oranges, true. So like that, these 3 decision trees have taken to understand random forest algorithm and combining all these decision trees. So this is decision tree 1, 2, 3. Now we have this, we are giving the new data. For example, this data, this fruit is given to random forest model. That means this model asked to classify. If you observe, there is no color. So that is, color is missing. So this is one of the feature of random forest already told. Even though data is missing also, it accurately predicts. So that's why random forest is famous. So now when this data is given, now decision tree 1 classifies it as an orange. So these are the features of this data. That means the diameter equal to 3, color equal to orange, grows in summer, yes, shape equal to. So forget about this color equal to orange. Why? Because we don't know color. That is missing. So for the time being, there is no color. So when this data is given to decision tree, then it is classified. So what is the decision tree one? So is diameter is greater than equal to 3. So diameter is greater than equal to 3. So it is true. So comes to this side. Is color equal to orange? So then it is finally predict that it is orange. Decision tree 2 classifies it as a cherry. So why? Because in the decision tree we have used the condition like is color equal to red and shape equal to circle. Decision tree 3 classifies as a orange. So what is the majority? Decision tree is giving orange. Decision tree 2 is giving it as a cherry. So decision tree 3 is giving as orange. So majority is orange. So it is this random forest algorithm is predicting it as a orange. So in this way the random forest works. Every algorithm, how it is accurately performing by measuring these metrics. So these are the different types of metrics like mean error ME, mean absolute error MAE, normalized root mean square error NME, like that. So every metric have its own formula. So depends on the algorithm and depends on the application, you have to use this performance metrics, whether that algorithm is accurately predicting the value or not. So these are some more metrics. So now our presentation is related to geothermal energy. So I will briefly tell about what is the geothermal energy, different types and operation, and give some design aspects. We know that the geothermal energy is a renewable source and it is a sustainable. That means that heat energy under the earth, it is available throughout the lifetime. So that's why it is a renewable energy source. Geo means earth, thermal means heat energy. So that is these two are the derived words from the geothermal energy. Why there is a heat under the earth? Because of radioactive elements like uranium and thorium. These radioactive elements generate the heat and radiates outwards. Then surrounding rocks will be heated. When there is a water available in that rock, then that heat is transferred from rocks to the water. Then water becomes hot water. This hot water can be extracted to the surface facilities like turbines and generators. Then we can generate the energy. This is the brief idea about geothermal energy. So if you see this here, you can understand what is conventional geothermal energy and enhanced geothermal energy. Conventional means it is natural. The geothermal reservoir is naturally available. Geothermal reservoir means that geothermal fluids which are available, that place is called as the geothermal reservoir. What are the geothermal fluids then? Hot water, steam, gases, all these are called as the geothermal fluid. These are the main resources for geothermal energy. So that is naturally available. If you go beyond the 2 to 4 kilometers of deep from the earth surface, so you can find the naturally available geothermal reservoirs. But if you want to go beyond up to 5 to 7 kilometers and artificially creating the geothermal reservoirs, then it is called as the enhanced. Why? Because if we go deeper, the temperature is increases. So that is called as the temperature gradient. So So there are three types of geothermal power plants. That is dry, steam geothermal, and flash. The one binary cycle. In all the geothermal power plants, basically it having the two wells, production well and injection well. So you have to drill the two wells. One is a production well, another one is the injection well. So I will tell that what is the injection well and production well when we are discussing the sequence of operations, reservoir operation. In dry steam geothermal power plant, directly the dry steam is used to extract the energy. This dry steam from the production well is given to the turbine, then turbine is rotates. We know the turbine and generator are coupled. When the turbine rotates, then generator is rotates, then it is converts into the electrical energy. Again, the exhausted dry steam is given to the condenser, where that steam is converted into the water, then water is given to the, again, the geothermal reservoir. This is called as the injection well. Why? Because you are injecting the exhausted steam, converting into the water to reservoir. So that's why it is called as the injection well. So this production well is extract the geothermal fluid from geothermal resource to the turbine. So that's why it is called as the production well. Similarly here also, in all the cases there are the two wells. So what is a flash type? In the flash type, load the geothermal fluid pressure is flashed. That means pressure is rapidly decreases. So when the pressure is rapidly decreases, then it is converted into the steam. So that steam is used to rotate the turbine, the same process. So that is the difference between dry and flash steam. Here directly we are using the dry steam, but here the pressure is rapidly decreases. That is called the flash. That's why it is called as the flash. In binary type, there are two types of fluids, primary fluid and secondary fluid. Primary fluid is extracted from the production well and it is in the heat exchanger. So you can see the extra equipment is the heat exchanger when compared to this. In the heat exchanger, there is a secondary fluid. This primary fluid transfers the heat to the secondary fluid. That secondary fluid is converts into the steam. Again, the same process. So this is the basic idea about these three types of geothermal power plants. On what basis these three power plants are classified? So it is based on the geothermal gradient. So as I told, when we go depth beneath the earth surface, that the temperature is increases. So that is called as the geothermal gradient. So the rate at which temperature increases with the depth beneath the earth surface, that is called as the geothermal gradient. So there are three types: average geothermal gradient, high and low. Average geothermal gradient value is in the range of 25 to 30 degree per kilometer. That means for every kilometer, 1 kilometer go depth, then temperature is increases 25 to 30 degrees centigrade. That is average value. High geothermal gradient means 50 degrees centigrade per kilometer. That means for every 1 kilometer depth, the temperature increases by 50 degrees centigrade. Low geothermal gradient, that value is in the range of 15 to 20 degrees. So this binary cycle geothermal power plants used in case of low geothermal gradient. So we are extracting the low temperature fluid from the reservoir given to the heat exchanger. Then that temperature is given to the secondary fluid, so that converted into the steam. And dry type and flash type is used for high geothermal gradients. So I think this classification is clear. So now how we can create the reservoir and how can we operate the enhanced geothermal systems? There are basically 3 steps. Step 1 is identify and study the site. So geologists or engineers or researchers, scientists study the area by conducting some surveys and images. Then they concludes that this area is suitable for geothermal. Then they will check the rocks, which type of rock is available, and the rock should have the permeability. We heard that permeability in case of magnetic systems. Similarly, that rock also here should have the rock permeability. That means it is ability to allow the fluids. That is called as the rock permeability. So after this, studying the given location and rock permeability, then we have to go for the construction, artificial construction of reservoir. So you have to drill the injection well. You have to drill the production well, like this. So this is injection well and this is the production well. So you have to artificially create the reservoir. So here, that means you have to create the fractures in the rocks. How can we create the fractures in the rocks? After drilling the injection well, then by using the hydraulic pressure, you have to pump the high pressure water through injection well to the rocks. Then rocks breaks, fractures. So then the water is allowed to flow through this fractured rock. So now the reservoir is artificially created. So that is the second step. Now you have to operate after drilling the injection well and production well. Now you have to operate. On the surface, we have to install the turbines, heat exchangers, generators, condensers, everything. So by using all this, now the heat energy we are extracting from the geothermal reservoir through the production well to the surface equipment, it converts into the electrical energy. So this is the basic operation of EGS. So what are the challenges while designing the enhanced geothermal? You have to predict the subsurface property. That means temperature. We have to, what is the temperature and what is the permeability, rock permeability. So those parameters are important while designing the EGS. So then reservoir performance optimization, energy prediction. These are the key challenges. Here I will explain geothermal, enhanced geothermal energy operation by taking some case study. So these are already in the literature. ML techniques are already applied in the geothermal energy by using these techniques. RF, just we discussed random forest. RF means a random forest. So they are applying this random forest application for mapping geothermal potential. So that means they are identifying the location where the geothermal potential is available or not. In this algorithm, they have used the parameters RMSE and NRMSE. Like that, different people are applying the different techniques for the different applications in the geothermal energy. So here also I'm using this case study by using the random forest. I already explained the random forest. once again, I'm giving some brief idea. This is the, for example, data set. So you have to split this data set. So by giving the conditions, it makes the decision tree like this. So this data set, this is the data set. What we have to do, we have to divide this initial data set into the different data sets like 1, 2, 3 up to n. Each data set makes each decision tree. Majority of decision trees gives the output that is considered as a predicted value. So what is the case study we are taking means geothermal energy prediction using machine learning. Our objective is to develop a machine learning model for predicting the geothermal energy. Problem definition is we have to consider this. So geothermal energy depends on the already told temperature gradient, rock permeability, thermal conductivity, subsurface temperature, all these parameters. By using these are called as the futures in the data set. By using, and also these are the independent variables. By using these independent variables, now we have to predict the geothermal output. That is our target. This is the problem definition. So here, so far it is okay. Okay. So next, we have to take the data set. So data is the foundational resource. How the temperature is the primary resource for geothermal energy. Similarly, data is also primary resource for machine learning. So we have to give the raw data to the machine learning. We have to validate, test, evaluate. Then machine learning will give the predicted value. So how can we take the data set? We have to take the data set from the different sources. So you can, this is the USGS, that means US government research. There is another one. And from the articles also, you can take the data set. In the data set, what you have to consider? So data set means it is available in the spreadsheet or CSV file or Excel sheet. It have the rows and the columns. So in that rows and columns, there will be the futures and target. What are the futures in our problem? Geographical coordinates. So that means latitude and longitude. So for that particular location, which location you have chosen, that location latitude and longitude is called as the geographical coordinate. Subsurface temperature, that means temperature within the earth beneath the surface. Rock permeability, already told, rock permeability means it is a ability to rock have the ability to allow the geothermal fluid. So the geothermal fluid may be available in the liquids or gases, whatever, but it should allow that geothermal fluid. So that is rock permeability. Thermal conductivity. Thermal conductivity means ability to conduct the heat. That means transfer the heat. So geothermal fluid transferring the heat from itself to rocks. So that is called as the thermal conductivity. So these are futures. What is your target? Energy is the target. By using these independent variables, and now we are predicting the energy. So after data set is ready, then we have to go for the methodology. So methodology, we are giving the raw data. So that raw data is not sufficient to predict the output. So there is no accuracy. So you have to pre-process the data. So what is mean by pre-process the data? Data cleaning is called as the pre-process. That means what is the data set which are available with you that may not have the complete data. Maybe some values are missed. Maybe duplicate values. That means the column which is repeated. And the data set having the both types of features. That means numeric values and categorical values. So numerical values means what? And categorical values means what? So for example, there is a data set. For example, this is the, assume that this is the data set you have. There is a, we have taken rock type and temperature. For example, we have taken. Temperature is a numerical value that may be 20, 30 degrees centigrade or Fahrenheit, whatever. Rock type is not numerical values. Rock may be graphite. This data, when you are giving this object to the machine learning, it won't understand. So this data is called as the categorical value. This categorical value should be converted into the numerical value. So that is done by the one-hot encoder. So before one-hot encoder, there is a label encoding. That means this gradient, this graphite is converted into the value 1. Why? Because numerical values only understand by the machine learning or computer. There is another type of rock that may be limestone. So limestone may be given to the 2. Like that, another type of rock is given 3 and the another one is 4. So now this string values, this object is converted into the numeric. This is called as the label encoding. So we are converting these rock types into the numerical values. That is called as the label encoding. Another one is one-hot encoding. This label encoding has the disadvantage that, so you are giving 1, 2, 3, 4, 5. So it understands that this 4 is superior than 3. So that means this type of rock is superior than this 3. So like that, the computer or machine learning understands. So that's why this label encoding is not usable. So one-hot encoding is used for converting numerical into the categorical value. Categorical values into the numerical. So how it is works? In one-hot encoding, these rows are converted into the columns. So that means here this is graphite. Similarly, there is a limestone. There is another one. So this graphite, first one given to the binary value 1 and this is 0. And another type, next we have the limestone. So here the binary value is given 0 and this is 1. So this is called as the binary encoding. So now there is no problem. Here the values are 1, 2, 3 for numerical values. So there is a problem with label encoding. For that, we are going for the one-hot encoding. All these operations are called as the data pre-processing. Now this raw data is converted into the proper data to analyze the machine learning models to give the predicted values. After data pre-processing, then you have to select the model. So what model already discussed, there is a linear regression, decision tree, random forest, like that. So you have to choose the machine learning model. After that, training and testing. So 70% of data used for training, 15% is used for validation, 15% is used for testing. So you have to split the data, given data set like this. Then interpret. So by after testing the data, so which future? So we are giving these futures, right? These are the futures we are giving. Which future is having the highest score to predict the value? Maybe that is geographical coordinate, maybe that is rock permeability. Out of all the futures, one future only having the highest score to predict the exact value. So that is called as the interpretability. So after that, we have to implement the code. So we have to implement the code by using the language Python. Here you have to import the different libraries. What are the libraries we have to import? Pandas. So why pandas? So here what we are doing? We are doing the data manipulations. All these data manipulations are done in the pandas. Next library is NumPy. So that means numerical Python. We are importing NumPy as NP, pandas as PD. So this is for data manipulation. This is for numerical operations. NumPy is for numerical operations. Next, for plots, you have to use the library matplotlib. It is like the visual representation how it is in MATLAB. Similarly, here also this. There is another one that is sklearn. Sklearn is called as the scikit. So here in this library, we have the machine learning models are there. That means random forest or regression models or classification models. Why we have to import all these models? Why, if you import all these models, then no need to develop the algorithm from the scratch. So directly you can import these, then you can use this for your application. So that is the advantage of importing libraries. See, column transformer. So that is already told. Here we are doing the column transformer. So this row, the process of converting categorical data into numerical data, we are converting rows into the columns. So you have to perform this operation under this scikit-learn. Then pipeline. You have to import this pipeline from the scikit. So what is pipeline means? So we are machine learning models works by step. First, data import, pre-processing, training, validation. You have to write the code for a data import, write the code for a pre-processing, write the code for training, write the code for validation. So you have to bring all this coding into the one set and execute that one. That is called as the pipeline. So one hot encoder, this is also already told. This is for converting the categorical values into the numerical values, and you have to do the scaling of data also. If the data is outside the range, then you have to scale down. So you have to import that one. Random forest regressor we are using, so you have to import that one also. We are training and testing the data, so we are splitting that one. So you have to import that one. And metrics, performance metrics also you have to import. So all these are you have to import. I already explained what is pandas, NumPy, right? After importing, then you have to load the data set. So already you should have the CSV file with you. Then you can load that one. This geothermal underscore data file having this data. This having number of rows and columns. Here I am only showing latitude, longitude, temperature, gradient, depth to heat source, energy output. These are futures. Up to these are futures, independent variables, and this is the target. By using these independent variables, you have to predict the energy. This data sheet must be available with you. Then only you can load the data set. Otherwise, you have to create the synthetic data. That means artificially you have to create the data. So by using the different commands. Otherwise, directly you can load that one. So after that, you have to define the futures and target. I already told these are the futures and this is the target. So from the data set, you have to use these commands to define the futures and targets. Then whether this data having the categorical values or not. So machine learning model won't understand the categorical values, only understand the numerical. So you have to identify that by writing this one. Then these operations, if there are no categorical values, then it will pre-process the data. Then create the pipeline. So I already told machine learning model, first data is import, pre-process, training, validation. So different coding you are writing, all these comes under one stage, execute at one time. So that is by creating the pipeline. It includes all the pre-process the data, train, including scaling, encoding, everything. So split the data. So for the training and testing, 80% of data is for training, 20% of data is for testing. Then fit the pipeline. After that, you have to predict the outcome. Then evaluate. How can we evaluate the model? So already told, evaluation done by using the performance metrics. So here RMSE and R square values. RMSE value must be minimized, R square value must be maximized. Then it will give the accuracy. So this future importance is only, it is optional when it is only when you are using the random forest. So that means I already told which future is dominant to predict the outcome. That is called as the future importance. Then you have to use the commands plot to visualize the results. So this is output. So how can we evaluate? By using these performance metrics. RMSE is 20.35, R square value is 0.85. And this is the future importance plot. So if you observe temperature gradient having the highest score, so that means this is the dominant factor to predict the output. Remaining all are having the minimum score. So this is future importance plot. This is optional. This is only useful in the random forest model. So this is one case study to predict the geothermal energy. So the different applications are there. So for reservoir characterization, optimizing, drilling and simulation. So they're different. So you can go for these different applications. Up to now, so far we have discussed EGS, then comes to the biomass. I won't go into the deep biomass. So we know that biomass is energy. Biomass energy is generated from the organic materials. So we know that bio means life, mass means organic materials. So by using organic waste, biomass energy can be generated. So this is the cycle of biomass. So trees and plants, wood products and agricultural wastage, all these are the sources. So these are the sources, animal residues. municipal wastage, forestry residues, even agricultural, industrial, all these are sources for biomass energy. So biomass energy can be converted into the electricity, heating, and for biofuels by using different conversion technologies. These are the different conversion technologies we have. By using this, you can convert into the power and different. What are the key challenges? Rainfall is influencing the base, temperature, soil quality, moisture content. All these are key factors to predict the biomass energy. So in the literature already these ML techniques are applied in the biomass energy. I will take the one case study. So predicting the biomass energy from the agricultural residues using ML. Same as that, just we discussed in case of geothermal. First you have to import the libraries. Then here I don't have the data set. So synthetic data I'm giving. So artificially I'm creating the data. That data I'm giving. So what are the crop yield, rainfall, temperature, moisture content, energy output. So this is the all are futures. This is your target. You have to load this data set. Again, same, define the futures and target, split the data for training and testing. Then again, I'm using here two models I'm using. One is random forest. Then another one is the support vector machine model for comparison. See, this is the output. So by comparing these two models, by using the performance matrices, mean absolute error, mean square error, R square. So which one is accurate? This MAE must be minimized. MSE also must be minimized. R square, this must be maximized. So if you compare this, here it is 0.9, but here it is 0.009. So here value is higher. And these errors also, absolute error, squared error also errorless. So random forest model is suitable for this application. So by visualization also, here the see this point very near to this line, but here it is far away. So random forest model is suitable. So I'm concluding that machine learning is capable to handle the complex and non-linear relationships which are like renewable energy sources. So that renewable RES can be capably handled by machine learning to predict the energy. So that I can be concluded from this. If time permits, I will show the coding in the Anaconda. Is the sir? Can I show that?
Okay, sir.
Okay. Is it visible, sir?
Yes, sir.
Yeah, this is Anaconda Navigator. You have to install the Anaconda Navigator. There are different toolboxes are there. So this Python language is written in the Spider. So this is the Spider. See here, geothermal energy. The whatever the code I have explained, that is already here. See, this is the, so first we have importing the libraries. So what are the steps? I have load the data, then define the targets and futures. So you have to identify the numerical and categorical values. So you have to perform all this what we have explained here. Then run this model. See, we have shown in the PPT. So that is a temperature gradient have the highest score to predict the value. So that is here. And RMSE is 24.9, R square value is 1. So this is for geothermal energy, and similarly there is a biomass energy. Say already told biomass energy I have taken the synthetic data artificially created. In the same way I am running this model. See, here you are getting the two graphs. So one graph is related to random forest and another one is related to this support vector machine. So this I already explained in the presentation. So by comparing this random forest algorithm giving the absolute values. So this is my presentation. If you have any doubts, you can ask. Whatever I have shown, that is it. So far it is visible, sir. That coding part.
Okay, sir. Okay, sir.
Yeah. So thank you for your attention.
Sir. Thank you, sir. Thank you, Ranjit sir.
Thank
For
you.
your valuable presentation.
Is it useful, sir?
So everything is useful, sir. So thank you for your presentation, sir.
Yeah.
For your valuable information, we are getting a lot of information about the AI learning, supervisor learning, unsupervised learning, and reinforced learning. And what about the importance of is a biomass? How to generate the geothermal power and biomass power, and also different softwares used in that energy conversion devices. So thank you, sir. Thank you for your valuable information.
Thank you, sir. Thank you all the participants for their patience.
Thank you, sir.
Thank you.
So all the participants, please leave the session right now.